and I am excited to. Thank you so much. There's a number of different ways that we can engage with one another, and I am hoping that we'll have a really good discussion with all of this. And so thank you so much for being here and for making time in your day today. We are going to be talking about our beautiful shared resource, water. And so I am going to give the floor over to some very competent, very wonderful speakers, but I want to first ask if, can I have Kate or John say that they're seeing my slides?
Yes, I'm seeing your slide.
Okay, perfect. Thank you. I appreciate that.
Yes, I can see it too.
Perfect, and thank you for being here. So just a few housekeeping notes, there will be an opportunity to discuss later, and we will be doing that by several different methods, and there will be an opportunity for you to raise your hands and say what it is that you're excited about or what you're observing in your own life. And we have a concept board, so we're going to try something new for this meeting. And I'm trying to multitask right now because there's a bunch of just stuff happening. I had corrected it, but it apparently is not happening. So we're just going to let people trickle in here and give it a few minutes. And we're excited again, and thank you for being here for this today. I'm pretty excited about this presentation for all of the panelists. And so again, we will be having guidance opportunities, and we will be collecting responses, and there will be a raffle. There'll be a raffle. We'll pull names for that on Monday, and I'll tell you a little bit more about how you can get in on this good action. And so I was wondering if Lindsay is on the call today. Lindsay, if you can hear me, if you are here, please unmute yourself and speak up. I know that there was a work session today, so maybe that is not available. So I was wondering, John, would you actually like to say some opening words for us?
Sure, I don't mind. Can you hear me?
Yes.
They can't see you if you want to be.
Okay, hang on, let me get that done. Stop share, and I will.
Do you want to see me while I'm doing this?
If you want, or if you just want to speak your words, that would be lovely too.
No, but if you click this, then she can. I never do it.
I clicked it. Good morning. Can you see me?
Yeah.
Okay. Well, bear with me. This is my first Microsoft team, and welcome everybody to this webinar. A very important topic for all of us, for anybody living on this blue-green marbled planet, that essentially water is life. We need to do everything to protect the quality and the quantity of it for our current as well as our future needs. And I think that's one of the things that our tribe is tasked with, especially with the personnel that we have, the various scientists. We developed the capacity to regulate, manage, and administrate these kind of resources. And it's an important one for not just our community residents and our constituents, but for all of those around us, all the living creatures that rely on water, and of course the way we manage water, that affects them as well. And of course, foremost, we want to ensure that those resources are available in order for us to exercise our treaty rights that is so indelible and so important to our membership. So again, just welcome everybody, and thank you for participating in this very important topic. What is in store for our people in the future, particularly with the effects that we're seeing with climate change, is something that we're all, of course, tasked with to address and be very methodical about how we're going to deal with this issue, and hopefully minimize any potential crisis related to it. So again, thank everybody for participating.
Thank you, John. That was wonderful. So I'm going to just kind of very briefly introduce things before we let our incredible speakers take over. And so this webinar is designed to be the first of the ones that introduce Chapter 3 of the Adaptation Plan. And so with some previous planning and projection documents, impacts to water really get kind of rolled into impacts with fish and can get lost a little bit in the way that we prioritize things. And so again, we're trying not to prioritize things with this plan. We're trying to find those overlaps where we have win-win situations. And so today's webinar is all about water. We'll be having subsequent webinars about all of these other categories and different priority species and ways that we interact with the food system. But today we just want to talk about water and the ways that water will be affected by climate change. And we have a really great slate of speakers, and I'm going to let them introduce themselves because they know themselves the best, and I'm really looking forward to their presentations. So without further ado, I am going to give control over to Kate. So I'm going to stop sharing, and hopefully that does it. So Kate, if you want to pull your slides up. Yeah, it looks great.
Is it showing up? Okay.
It is.
Slideshow from the beginning. Okay, let me minimize you in the corner. Okay. Well, good morning and greetings. I'm Kate Ely, hydrologist for the Confederated Tribes of the Umatilla Indian Reservation. 3 tribes, the Walla Walla, Umatilla, and Cayuse, so were brought together by the Treaty of 1855 as a sovereign nation with reservation lands in northeastern Oregon and ceded 6.4 million acres in Oregon and Washington, and with the hunting and fishing rights and usual and custom sites and in parts of the western United States. So my presentation is water, cuus, surface water and groundwater for first foods and people. Okay. This is an overview of the topics I'll be highlighting today. There's quite a long list, and this is a relatively short program for this list, but we'll get through it. Okay, and hopefully you'll have a better understanding of surface water, groundwater, and their inseparable connection, and the understanding of the water cycle and the human effects on the water cycle, watershed, and first foods. And then we'll look at climate change and what is anticipated and the impacts to first foods. So lastly, we'll look at what we can do to combat climate change. Okay, so I work in the Water Resources Program, and our goal is to ensure clean and adequate water to produce first foods, and also to ensure water supplies for economic and community development of the reservation. Okay, but we also manage tribal water resources for sustainable use under a changing climate. Okay, so what are the first foods? Let's look at those. They're cuus, nusuk, yamish, cuus, and wiwinu. In other words, water, salmon, deer, cuus, and huckleberry. And within the Department of Natural Resources, we have a mission statement that was adopted in 2007, and that's to protect, restore, and enhance the first foods, the water, salmon, deer, cuus, and huckleberry, for the perpetual cultural, economic, and sovereign benefit of the CTUIR. And we will accomplish this utilizing traditional, ecological, and cultural knowledge and science to inform population and habitat management goals and actions, and natural resource policies and regulatory mechanisms. And the department has developed 2 guiding documents to help us implement this mission. The first document is the Umatilla River Vision, and it's to address the interconnection of the first foods and people's responsibility to protect and enhance those first foods. The 5 touchstones are aquatic biota, which are fish, bugs, and the like, all that living. The riparian vegetation, the plants along the stream corridor. Geomorphology, the landform. Hydrology, which is both the water quality and quantity in stream flows. And the connectivity of the river, the floodplain, and groundwater. And the floodplain is basically river deposited sediments that we would have in this area along the river. As we will see, the water in the rivers is mostly supported by groundwater. In 2019, the department developed the First Foods Upland Vision. And these are, this is the second document to assist us in protecting, enhancing the first foods. And common to these two documents is the fundamental touchstones of the interconnection of the first foods, the land and landforms, the hydrology, and the biota. Okay, so now let's look at the world's water and distribution. And this is an image from NASA that shows the eclipse crossing North America. But let's look and we'll see the area on the surface of the earth is covered by water. And of that water, 97% is ocean water, not drinkable water. And 3% is fresh water. So of the 3% fresh water, most of it is tied up in the ice caps and glaciers to the north and south of us and on the high elevations, 69%. And then groundwater supports 30% of that fresh water. And then accessible surface water is really just 1% of all the fresh water. Now let's look at what is available as far as fresh surface water. 52% of it is in lakes, 38% is in soil moisture, and 8% in water vapor, which is the water in the atmosphere and clouds, and 1% of that accessible surface water is in rivers. So basically water that we see in stream is 1% of accessible fresh water, and 1% of surface water, and of 3% of all water. So there's very little fresh water that we have available to us. It is a finite resource, and it's very important to all of us. Okay, so let's look at the watershed. And what is a watershed? It is basically the area where a drop of water will drain to a major river system. And in our case, our watershed is the Umatilla River Basin. So this is the outline of the highest area along the basin, and all the water that falls in this river basin will migrate towards the Umatilla River and out to the Columbia River. The Umatilla River is a sub-watershed of the Columbia River Basin. So the Umatilla River also has a multitude of sub-watersheds, for example, from Meacham Creek, Mackay Creek, Butter Creek, and Wild Horse Creek, the like. So now in our watershed, we have the Blue Mountains to the southeast and the Columbia River to the north, and the Umatilla Reservation in the foothills and mountainous areas of the Blue Mountains. All right, most of the water falls in the Blue Mountains. We have as much as 50 inches of rain and snow. We call that precipitation. And it's semi-arid to arid in the lower Umatilla Basin with 7 inches of rain and snow. And for practical purposes, very little of that water actually reaches the groundwater system. So it's believed most of the recharge that happens to the groundwaters is in the upper basin where most of the rain falls. Okay, so let's look at the water cycle. This is a complex diagram that shows many aspects to the water cycle and the free flow of water to in many directions. But let's look at the 3 basic elements in these big lines here. This is the evaporation that occurs from surface waters to the atmosphere, and we have then condensation to precipitation as snow and rain, and then we have runoff down along the surface in the watershed as we spoke, and also groundwater runoff in the subsurface in the watershed. So each of these is a discipline unto itself in which to study, but those are the 3 major categories in our water cycle. The water budget in our Upper Umatilla River Basin is basically something that we outlined here in diagrams of where water flows. So we have the evapotranspiration, which is evaporation and transpiration from plants combined into one word, precipitation, and then we have the runoff along the river. We have springs discharging in the foothills, mountainous areas, and we have groundwater development from domestic wells, municipal wells, and agricultural wells. This picture also illustrates that we have recharge to the shallow and deeper basalt aquifers, and we'll look at the flow paths of groundwater in another slide. But notice that there's soil moisture along a thin veneer here too. So this is what people have done to monkey with the water cycle, and they've redirected water, dammed it up, leveed, and the like, and have really altered the course of water. But we see we have the evaporation, the evapotranspiration, cloud formation, but we've also attempted to, seed clouds and try to produce more rain, more precipitation. We have runoff, we have irrigation now development, and diverting of water to fields, water for livestock, and water for cities. So I jokingly say that now water flows to money. So what is groundwater? That's one of the first things that we need to understand, is that groundwater is not underground rivers like we see on the surface. Groundwater is really water that occupies the pore space between these rock grains. Okay, so this is saturated material with water, and above the water table, it's unsaturated soil and grains and air and water. So we have what soil moisture in what we call the vadose zone above the water table with air and water, and then below the water table, everything is saturated, 100% saturated with water in the rock formation. Imagine a jar of rocks, dry rocks, and then take about a third of that space, and then you could pour water into that jar of rocks to occupy the pore space. And that's how much water is in rock formations. We really have a lot of water and storage capability in the subsurface. And that's why we have 30% of all our fresh water is in groundwater. There's a lot of storage down there. Okay, so this is an example of the water table, and you've heard that probably many times. Okay, so for the most part, groundwater is invisible. We really don't see it in the subsurface. But we do see it in springs and seeps in the hillsides. This is Homley Springs on North Reservation. And these clumps of trees are springs as well. And they're self-feeding kind of vegetation growth and development, with water providing source for tree development. And then there's organic matter that then provides support for soil structure and development, and it's a feeding cycle into itself. So we have more trees with the water, and you can see this is a cluster of trees in a line, and that might be from the groundwater discharge area along an interflow zone. And sorry I didn't mention the interflow zones in the previous slide where we get our water. We'll see it in another picture, however. Okay, we also see it in cisterns and boreholes. This is a moonshine cistern where we have a spring bubbling up here that was developed, and then if the valve was closed, it would fill this cistern. This is looking down a well, and that's the water table. That's everything below the water table is saturated ground, and above it is unsaturated with the air and water for soil moisture. So that's a cool picture of what it looks like in the borehole. And we see groundwater in rivers and creeks, and it's like, well, wait a minute, this is surface flow, right? This is what we just talked about, that 1% of 3%. Well, surface water is mostly supported by base flow, which is groundwater discharge. So that base flow is something that's a kind of a new concept for many people. Okay, so let's look at what base flow is, and we'll see that an interconnection of groundwater, surface water. So here's a picture illustration of the Umatilla River in Pendleton. We're looking at the 8th Street Bridge here, and this is the river levee and the Blue Mountains in the background. And in the subsurface, we have the basalt flows that we see in the landscape, right? And the stage of the river, the height of the river, and then this is the water table and the alluvial depositional material that would constitute the floodplain that we mentioned in the river vision, the connectivity of the river to the floodplain. And as this illustration shows, there is a disconnect of the Umatilla River and high waters flowing out into the floodplain because the levee prevents it. So it's contrary to the river vision and a fully functioning river system. So beneath the river and in this, we have those basalt flows. And between each basalt flow is an interflow zone along here. And if it's, if it stores water and transmits water, then we call it an aquifer. All right, not all groundwater are aquifers, but if there's, again, sufficient flow and storage in a rock formation, it's called an aquifer. All right, so this is how groundwater, surface water is connected, and this is how the river is supported by base flow or groundwater discharge. This image shows the water table sloping away from the river, so this is a losing reach of river. And if the water table was, for instance, higher than the river, then it would be a gaining reach. So let's see now how we measure how much base flow is in the river. And this is a picture of a gauging station in Gibbon, Eastern Reservation boundary, and Umatilla River. And it measures the height of the river, and we relate that height to a specific discharge. And so with different heights, we have different discharges. And the gauging station, this is a hydrograph of the average flow for the period of record, 82 years of record. So these are daily average flows and shows you where most likely going to have high flows and low flows. Whoops, sorry. So these are the flow rates in cubic feet per second. And this is the calendar or the water year beginning October 1st and ending September 30th. And these are the high flow periods, and this is the low flow period. Throughout this entire period of record, you know, groundwater and surface water are connected, right? So there's base flow throughout the year. This red line shows the average monthly flow, and through analysis of the hydrograph and the record, we can determine how much of this is base flow and how much of this is surface runoff. Okay, so this is the average monthly flow at the Gibbon station, and the average annual is 230 cubic feet per second. And through that analysis, we determined that 20% of the annual flow is actual surface runoff and 80% is base flow from groundwater. Most of that base flow is coming from a very local flow system. All water needs to do is seep into the ground through the soil to a water table, and it then discharges to the river. So the floodplain is integral to this support of base flow in the river system. And groundwaters not only provide the water quantity, the supply in water, but it also moderates the stream temperature of a stream. Have you ever noticed jumping into a pool in the river and all of a sudden it's cold at depth? And well, that's groundwater discharge to the river system, and it helps moderate the stream temperature. So this is the Umatilla Basin watershed that I had pointed out, and underneath the entire watershed is that Columbia River basalt system. And we get our drinking water mostly from the basalts, though there's some people who draw from the sedimentary deposits. So the next slide is going to be a cross section across this river basin, and we'll look at how we share the entire groundwater system. All right, so here's that cross section from the Columbia River to the Blue Mountains, and the Umatilla Indian Reservation is out here. And this is vertical exaggeration, a considerable amount, but to be able to see these wells in relation to each other. This is the Hermiston area in Stanfield, and these are typical irrigation well depths. And here's the city of Pendleton, typical irrigation well depth, and the tribes have several deep wells as well, which is, this is an irrigation depth for well 4. So you see that we all share this basalt formation, and we share the aquifers in the Umatilla River Basin. These are the basalt aquifers. And we have a considerable amount of irrigation development in the lower basin and relatively little irrigation in the upper basin. We have mostly dryland wheat. This is important because areas where we have high development, high capacity wells, we have groundwater overdraft, meaning we're mining the groundwater. Since wells have gone in, water withdrawn in a high producing way, water levels have declined. And over the 70 years, it's declined as much as 500 feet. We'll look at some hydrographs of that in the future. And these, in 2012, some recent studies have identified that the water level declines observed in the lower Umatilla Basin are also observed in Pendleton, and they share the same hydrologic system, and that's been shown. And Pendleton's observed about 100 feet of decline, and like again 450 in the lower basin. These faults here have broken up the continuity of the groundwater flow system, and we do not see water level declines on the reservation, and this could be because of a couple of things. One, the faults and compartmentalization, and we don't have high development on the reservation. So we are, and we'll see those hydrographs. So these water level declines prompted Oregon Water Resources Department to implement critical groundwater areas, and the next map is going to show those areas. We have the Stage Gulch critical groundwater area, Butter Creek, Ordnance Gravel, and Ella Butte. And Pendleton is not in a critical groundwater area, though I said they share the same aquifer. This, things are evolving and our understanding of the flow system is developing. But Pendleton has worked to counter the groundwater level declines with aquifer storage and recovery. Okay, so let's look at the, here, we're going to look at water level declines in the Butter Creek area, in Pendleton, and on the reservation in Mission. This is a hydrograph of the groundwater levels in the Butter Creek area. And this well, when it was drilled in 1953, it was near ground surface. It was almost a flowing artesian well. And over the years, with development and mutual development, neighboring wells, the water levels have declined. And this is as much as 450 feet over those years. And with the implementation of the critical groundwater management areas and cutting back irrigation use, the water levels are starting to stabilize, though they have not. This is the city of Pendleton well, and this has had almost 100 feet of decline, and with the aquifer storage and recovery, we're getting a slower rate of decline and hopefully in the future some stability. This is a reservation monitoring well. There's no development on this well, though we see on these monthly readings that there is seasonal effects on the groundwater levels. And every year, however, the water levels recover. So there is not, if we were to just plot the spring highs, like these are spring highs, we would see a very straight line. But with development, we have mutual interference and we have water level variability through the season. The tribe's water code implemented restrictions on groundwater development in the Mission Basin in this area and have limited use to 25 gallons a minute, and that has arrested these seasonal, this extreme seasonal variability, and now we have little well interference. Okay, so let's see what we've done to the water cycle and to our watershed. And this is a complicated slide, but what's important is that it shows areas, the white arrows and the red areas shows areas where people have affected the water cycle. White arrows are natural processes taking place, and the red arrows is people affecting process. And the black lines is the basic big regional flow system directions. Okay, so in the Umatilla, like this picture shows, we have a big regional system like would occur in the deep basalts. And then we have an intermediate system like the foothills to Pendleton or to the other areas. And then we have a local flow system like from what would occur in the floodplains and along the river. And in this we have roads, we have wells, we have septic systems, we have farming operations, we have mining operations, and all of these areas are places where we can pollute our water resources. We can add nitrates, like in the lower Umatilla Basin, overlapping all that critical groundwater area. Well, most of the lower area is a groundwater management area declared by the Department of Environmental Quality, and it has high nitrate contamination. It's been going on for 30 years plus. It's difficult to treat groundwater once it's contaminated. Fortunately, we are not experiencing that in the Upper Basin. But we do, on the landscape, affect our water cycle, as I showed in the cartoon previously, that we redirect water, we pollute water, and now, this was a 1980s poster, and this was before, there's widespread acceptance of global warming. Now people are, people are affecting the atmosphere and the global cycle, the global water cycle, and we are heating up the planet, and that causes more evaporation, more water is a greenhouse gas, more water in the atmosphere, which is then changing our weather patterns and our precipitation character from in the Pacific Northwest, from rain, snow to rain. And so this is a major global aspect of our water interference, you might say. All right, so with global warming, we have some predicted future conditions for the Pacific Northwest. Scott O'Daniel will be talking about future flows in the Umatilla River Basin, and I extracted these bullet points from Kyle Dittmer when he did a 2015 presentation for the tribes. In his presentation, he discussed these points. An increase in average annual temperature ranging from 3 to 10 degrees Fahrenheit by the year 2100. The annual precipitation is projected to either decrease or increase from negative 10% to positive 18%. So we'll have throughout the region, we'll have positive and negative total precipitation. There is virtual certainty that extreme cold days and nights will be warmer and occur less often. There's virtual certainty that extreme hot days and nights will be warmer and occur more often. And it's very likely that frequency and duration of heat waves will increase. And this is related to the heat waves in the summer within a year. And it's very likely that heavy precipitation events, the frequency, intensity, and/or amount will increase in our region. Well, this was a 2015 slide, and while last year we had a flood of record where we had quite an intense, we had considerable snow and then warm Pineapple Express atmospheric river come in and melt all the snow in the lower parts of the basin and just provide us a deluge of water for a flood of record. And it's likely that drought will increase in duration and/or intensity. And it's likely that low-level mountain snow will decrease by 40% for April 2040. Now, low-level mountain snow, that's significant. We rely on that snow for groundwater recharge, the slow melt and the slow infiltration of groundwater. Okay, here's just a break between slides of text, and this is the Blue Mountains with snow in the hills, and this photo is from Eric Klemps. So the implication of global heating, climate change on the first foods. With warmer annual temperatures, we anticipate changing weather patterns, changes in snow distribution, and a period of snow melt. So less snow and early onset of snow melt will lead to less time for melt to seep into the ground as soil moisture and as groundwater recharge, as I mentioned earlier. Less groundwater recharge means there's less groundwater discharge to streams and springs. Remember we talked about the base flow component? Less groundwater discharge to springs means there's less water for trees in that image of the Blue Mountains with a spring and a seep. Less groundwater discharge to streams results in less in-stream flow and less moderation of stream temperature, so temperatures in streams will rise. And with higher temperatures, there's more algae growth, there's less oxygen, less biotic diversity, poor aquatic habitat conditions for first foods. Here's another break. This is salmon spawning, adult salmon spawning. So this is continuation. So less spring runoff and warmer waters will have impacts to the life cycle of salmonids from spawning, incubation of reds, emergence, rearing, outmigration, and adult returns. We'll probably have a presentation on the effects on salmon in the future. So less water and warmer water in stream will result in less first foods. And so, you know, as well as the impacts to the first foods, will also have more and greater intense floods, more and longer droughts. It will be harder to predict the water supply, and water management will be more difficult due to the extreme weather conditions. How do we plan for, you know, crop growth and water releases and the diversions that we employ on water? And in addition, with that early onset of snow melt, we'll also have, and warmer temperatures, will have a longer growing season. So that means there's more demand on shrinking water supply, which also pits irrigation water against in-stream flows. So this is a picture in February. There's no snow. Notice there's no snow. This is February 2020, overlooking Thorn Hollow and the Eastern Reservation. And this is after the storm had melted all the snow and we had a record floods in the Umatilla River. And you can see the river from a great distance here. All right, so what can be done to adapt to the changes in climate? Well, we can implement river vision and first foods upland vision. That's an important aspect. If we're doing what it calls for, we will be protecting, enhancing the first foods and adapting for climate change. So we can promote natural storage in floodplains, less levees, groundwater recharge and development of ponds, more beaver action. We can reduce greenhouse gas emissions by using more green energy, such as solar and wind, and less fossil fuels. Ride your bike, walk to the store, do what you can. And we can plant more trees for carbon sequestration or storage of carbon. We can increase our climate stations. You saw in the pictures the mid-level elevations, but we don't have any monitoring sites in those mid-levels, so we don't know how much snow and how much rain falls in those areas and the changes that might occur with climate change. And most of all, the things that we can do is we can conserve, we can employ conservation in all aspects of our daily life, reduce, reuse, recycle, repurpose, and reduce those greenhouse gases. Okay, so sustainability of tribal people and culture is directly related to the success of first foods, right? Okay, and the corollary to that is what's good for tribal people is good for America. This came from an Anton Minthorn quote during Water Commission. And so it behooves us all to protect, restore, and enhance the first foods and to adapt for changing climate. Okay, that's all. Thank you.
Thank you, Kate. That was awesome. If you could stop sharing your screen and
Okay.
Perfect. Well, we are going to have Scott O'Daniel speak next. He was not able to be here in person today, so we have a pre-recorded version of his presentation, and so I'm hoping that this will go smoothly. So let me know if, Kate, will you let me know if something is not working? Do you see future flows for the Umatilla River? Kate? Or maybe somebody else can just give me a confirmation that they are seeing the slide that says future flows for the Upper Umatilla River.
I see it.
Perfect. Thank you so much. So we're gonna play this now.
Thank you. My name's Scott O'Daniel. I work for the Umatilla Tribes GIS program. Today I'm gonna give a talk entitled Future Flows for the Upper Umatilla River. The work for this talk has been done by myself and my colleague and co-author on this project, Bethy Rogers-Pacheco. Today I'll be presenting some of the results from a hydrologic modeling exercise that incorporates changing precipitation, air temperatures, and atmospheric carbon to forecast stream flow into the late 21st century for the Upper Umatilla River. This talk will highlight some of the model outputs and the types of changes in the future stream flows that we anticipate. These two slides show the annual average precipitation, both rain and snow. To orient ourselves, the state line is shown in the middle in a thick black line, and the Columbia River follows part of that line up to the Oregon-Washington border. The Umatilla and Walla Walla rivers are clearly shown. This legend applies to both maps. On the right side is the annual average precipitation from 1971 through the year 2000. I meant on the left side, the legend shows precipitation from annual averages from 1971 through 2000. On the right side of the map is the predicted precipitation from near the end of the century. There's a little more precipitation that's shown in the future map. While the annual average precipitation is likely to increase in the future, much of it will fall in the form of rain rather than snow. Again, these two maps show the same area, but display something called the snow water equivalent, or another word for snowpack if it were melted down into water. These measurements are taken or predicted on January 1st on the left, and again on the right is the future forecast. January 1st is important because it is historically part of the snowiest portion of the year. The goal of this project is to take information like this, predictions about flow in the Umatilla River. Before we can do that though, we need to understand the physical attributes of the Umatilla River watershed, things like land cover, slope, and soil. It's also worth noting that the snow water equivalent on the left, the historic range, is dramatically lower in the future, shown on the right. So back to understanding the watershed and some of the land cover, slopes, and soils that dominate hydrologic flow through the basin. We used a standard USGS cover map of the Umatilla River watershed. Remember, we're modeling the upper part, or above Pendleton, on the Umatilla Reservation and on the National Forest Service land. This land cover pattern reflects a precipitation gradient of rainfall, moving from drier areas in the western portion of the basin, about 7 inches of annual precipitation near Hermiston, to relatively high precipitation in the highest parts of the basin, over 40 inches of annual precipitation. We'll show modeled stream flow at 2 USGS gauges along the Umatilla River that collect water from different areas and show different combination and characteristics of land cover, soils, and slope. Here we show some of those combinations of land cover, soil, and slope. The image in the upper left corner is our study area, the colored part. In order to realistically simulate the movement of water through the landscape into the river, we divided the Upper Umatilla River watershed into 36 subbasins, shown in the gray images below. Next, we combined attributes of the soil water holding capacity, the slope, and the land cover to model the movement of water through the landscape and into the main stem river. Examples of each of these subbasins and the soil, water, slope, and land cover characteristics are described in these smaller maps. We used 2 gauges with historic data to compare the changes of the flow at Gibbon, shown here in the Upper Umatilla Basin, and at the West Reservation boundary, shown to the west. The east-west orientation of the basin is very important because large winter storms, sometimes known as atmospheric rivers, move in from the Pacific, often up the Columbia Gorge, and into the Umatilla, as shown by this animation. This basin orientation affects the hydrologic response of flooding because the storm saturates the lower basin first. So when runoff from the upper basin arrives in the middle and lower floodplains, they're already full of water. These effects can be detected by analyzing the hydrologic record of the gauges along the river. Some example flows from the Umatilla River are shown here. The top image shows a flood on April 9th, 2019, where the Umatilla River at the Mission Bridge carried approximately 3,500 cubic feet per second of water. The lower image, taken on November 5th of 2019, shows near double that volume. So in order to try to communicate the model outputs, we compare the 88-year record at each gauge, in this case Gibbon, and the distribution of monthly average flows across the year. The highest March flow that was ever recorded is the very top bar, the dark blue bar with the value 37. That was in 2019. The dot in the middle of each of the bars represent the average, and the medium blue bars show the range from the highest among the flows each month. As you can see, there's great variability within each monthly average. The difference between a wet year and a dry year can sometimes be up to 10-fold. Historically, the wettest months have been in the spring, and winter snow melts. Here we show a graph for the West Reservation boundary that shows similar information. The average monthly flows at the West Reservation boundary gauge are shown over a 26-year record. The distribution of flows looks similar to Gibbon, but with increased flow volumes that represent more water flowing into the catchment downstream. Monthly variability is also quite high. Again, up to a 10-fold difference in the range, for example, April, and the annual peak is still centered in the spring, in April. Again, the dark blue bar at the top of April shows that in 2019, April flows were the highest that were ever recorded for the month. These next two slides will compare some of the historic data and the modeled data. Modeled data will show our predictions in 2080 from outputs at Gibbon and the West Reservation boundary. The blue bars show the same data that you saw on the previous historic slides, and the red or pink bars show the modeled flows from 80 model runs based on a high emission climate change scenario in 2080. Note that the vertical axis or the range of data has increased. Modeled winter flows show a large increase from the historic range. These models suggest that by the end of the century, a wet month could far surpass the spring floods anytime between November and May. Even the average March or April flow could exceed the historic record. Additionally, the variability increases on the low side as well. Many of the examples of this are in January, February, and March. If you remember back, this is mostly because rain represents the precipitation falling in winter rather than snow that would have fallen historically. Again, the gauge at the West Reservation boundary shows a similar pattern. Wet months could be much wetter than the historic record. Dry months could also be much drier than historic averages. With the exceptions of January, February, and March, which aren't predicted to be as dry as the historic data, again, because precipitation is falling as rain rather than snow. And so the precipitation has no lag as it contributes to the river. The magnitude of these results were unexpected, and we sought out other models to compare with ours. This graph shows results from a University of Washington study for tributaries of the Columbia River. This is the Umatilla River at Pendleton. The pattern of these results are very similar to ours, including high monthly variability. The University of Washington used different methods and different data sources than we did. The units on the y-axis are different for these last slides. They used the depth of water across the entire watershed to represent flow, but the patterns are very similar. High winter variability is found in both the Umatilla on the left, the Walla Walla in the middle, and the John Day on the right. These results led us to believe a big part of the story is the natural variability of weather patterns and the responsiveness of rivers to individual storms. You'll remember the high-tech animation earlier and the storm path in the Umatilla that crosses from west to east. Our initial conclusions from this work is that increased flow variability is predicted for the Upper Umatilla River. The form of precipitation changes from snow to rain, and the Umatilla River will likely receive higher winter flows. Regional scale climate patterns will likely increase the frequency and the intensity of these flows toward the end of the century. Additionally, patterns of predicted stream flow for the Upper Umatilla are consistent with regional forecasts, like those from the University of Washington. These results have implications for native fish and aquatic animals that will be widespread. And it's important to remember that these floodplains where the rivers, the landscapes of the rivers are their own landscapes and should be managed as such. Floodplains are largely self-maintaining, and there's ecosystems on the planet. There is initial guidance for this kind of management in many documents, including the Umatilla River Vision, Floodplains by Design, and other guidance from the Association of State Floodplain Managers. It's also important to remember that salmon have withstood many harsh conditions over the last 10,000 years. They've reestablished in many unhospitable environments like the Toutle River after the Mount St. Helens eruption. And if our modeling is correct, we anticipate that the life history of Chinook will be the most impacted from future changing flows. Thank you very much.
So as you heard, there has been a really extensive modeling effort to look at the Umatilla River. And so we were really happy to have Scott. I know it was a little choppy, and so I apologize for that, but we'll post that on the website and so you can re-see it. And the slides were somewhat cut off. So I had sent slides out to people previously, but I know there are people on here that maybe didn't register, so I'm happy to get those out to you again afterward. So I wanted to give the most important word, the last word, to the governance of the tribe. The tribe has been governing itself for time immemorial, and that includes water on the Umatilla Indian Reservation. And so now I would love to have John Barkley. Can you unmute yourself and let me know that you can hear me?
I can hear you.
Perfect. So I know that you had some slides. Do you want me to show those slides, or are you going to try and share them yourself?
I'll pull them up myself if I do this right.
We'll let you know.
There it
I
is.
can see them. They're beautiful.
Can you see it?
Absolutely.
All right. Let's see. You have to excuse me. I need to get my glasses on here.
I think the icon just a little bit up from where you're going is the present one.
I need to start this. Can you folks see me?
Yes.
Okay. All right. Well, thank you, everybody, and thank you, Kate and Scott, for those intriguing presentations about the science behind the status of our water supply and the changes that we've seen over the past decade, and of course, trying to contemplate what's in store for the future of water resources for the tribes in particular, and how it impacts our first foods, river vision, and those things that they referred to earlier. Again, good morning. I'm John Barkley. I'm chair of the Tribal Water Commission for the Confederated Tribes of the Umatilla Indian Reservation. I've been on this commission for about 26 years now, and had the privilege to sit with a number of elders. Some are no longer with us on this commission, and have served as mentors for me and various commission members who have served over the time. Governance of water is very important, And, you know, we go back as far as when the reservation homeland was established with the Treaty of 1855. It was mentioned about the Aboriginal lands of 6.4 million acres in eastern Oregon and southeast Washington, and that tribal members essentially effectuate their treaty rights throughout this area, even beyond that, going back to Wyoming, Montana to hunt for buffalo, for example. We have about 3,150 tribal members and are the largest employer in eastern Oregon. The tribes adopted a tribal water code back in 1981 when the Board of Trustees, the tribal governing body, adopted that. And it was an interim code at the time. Of course, the code reflects the traditions, the culture, and values of our tribal people. And the foundation of our culture and cited in the water code is Tumunwit, or Creator's Law, which is both religion and law. And it states that water is medicine. Water is medicine to our people and to everybody. And some of the recitals in the introduction part of our code, I'd like to just, you see them there in front of you. It is the respect of all aspects of Indian life, and it is the way of life. We must share water with all living things. It is essential for the survival of all life. Cold, clean water is the lifeblood of the land. Cuus, as we call it, cleanses and heals our bodies. The purpose of the code is involving water management, allocation, and development, which shall benefit the Confederated Tribes, its members and residents, and promote the purposes for which the reservation was created, to provide a permanent homeland for the members of the Confederated Tribes, protect the exclusive fishing rights as set forth in the Treaty of 1855, and preserve the cultural and religious integrity of its members. So, as Scott alluded to earlier about the potential impacts associated with climate change upon our treaty resources, particularly salmon, is very precarious and something that we take very seriously, because we've enjoyed some good times fishing out here in the Umatilla Basin. A few years ago, about over 7,000 were in the system, and but the last 2 years it hasn't been as good. Also, continuing with these purpose, you know, it's to provide an orderly system to sustain and develop water resources, and to ensure that our residents have adequate quantity of clean water for domestic purposes, and it's to protect the water resources from over appropriation, pollution, contamination, degradation, and other acts to the quantity and quality of water on the reservation. You know, these are very essential because as we've experienced and are faced with, is that there is a considerable competition for water. And as Kate alluded to earlier, water is a finite resource. There's only so much to go around. To understand what that supply, that quantity is, and how we can best manage and utilize it for our values and interests is certainly based on the science that we have and are gathering, to make sure that we follow these caveats that are outlined in the purpose of this code. Again, to protect and conserve the quality and quantity of natural cultural resources in the stream zones, and ensure that the water rights reserved pursuant to the treaty receive the first priority in use and appropriation, protected and developed for the benefit of current and future generations of tribal members, and that the tribes retain full management authority over all reserved water rights sufficient to satisfy the purpose of the treaty and the homeland and members of the tribes. It is important that in the context of the tribes that we have been pursuing a tribal water rights settlement for the past decade now, and we're getting close to the cusp of completing our negotiations with the various stakeholders or parties involved in it, but it is an important element of the tribes in that since 1855 we have never quantified or settled our water rights, which is ironic in a sense that we're the first inhabitants of this area, and have been around for a while. The code also cites jurisdiction of the tribes, its sovereignty, of course, that we possess inherent sovereignty to govern the use of water within the reservation boundary. The authority, of course, is coming from our tribes, and we also have some provisions in the Clean Water Act, and that relates to the waters within the exterior boundaries. I want to talk about that a little later. And then the jurisdiction, again, to here review and decide issues brought forth pursuant to the provisions of the code and applicable regulations. There is a civil authority in ruling on matters arising under the code, in which the Umatilla Tribal Court has the authority to assess and collect civil penalties, and actually will review and hear these cases as they come. So again, our jurisdiction up to our tribal court to help resolve any issues. There's also, of course, as with a number of areas that the tribes are engaged in, policy is always set to drive us and give us a sense of direction as to, you know, why are we doing these things and what direction we're taking with it. But in our policy, it covers a number of areas that are segmented down, and I'm not going to elaborate on individual specifics in these areas, but they include the use of waters permitted by the tribes, goals of water management, treaty water rights, use of water without waste, water conservation required. I think it's one of the things that we emphasize is that let's not waste water. Let's conserve it as much as possible. Use it, of course, very methodically, in a sense, as Kate alluded to earlier. We don't need to deplete our aquifer as we have seen in the lower Umatilla Basin. So we want to protect that groundwater, because essentially we rely 100% on groundwater out here for our consumptive needs. We also groundwater conservation, competition for water well interference, water use for development on the reservation. And as you see that we are growing. We are one of the largest employers. We have 4 primary entities in the governance, Wild Horse, our Yellow Hawk, and Cayuse Technologies, with over 1,700 employees. We're looking at, of course, expanding in the future. We have a well number 6 that's coming online here in the near future that will help meet our increasing needs for water out here. We also want to, of course, reserve water for human consumption, provide water for fish and wildlife resources. As I said earlier in our introduction, that water is for all living things. Protection, provide water for wetland resources. Wetlands, of course, are a valued component in any system and in any basin, and we certainly want to protect those, if not enhance them, for the benefits of our treaty resources. We also want to protect stream flows and stream zones to make sure they're not impacted or degraded, to ensure that we always have the quality there needed for our needs. We also have watershed protection, water quality, anti-degradation policies, pollution and contamination prohibited, pollution prevention. And we do that with our water quality standards, and very important that we continue to protect the quality of water out here. And then intergovernmental cooperation and coordination. As you know, that anytime that we're addressing water issues that not just on the reservation, but proximate to the reservation, and of course within our Aboriginal lands, that 6.4 million acres, anything occurring out there impacting those water resources, the quality of it, the supply of it, we want to make sure that we have a voice in there too, and that these various stakeholders and intergovernmental agencies certainly are cognizant of what our values are, where we intend to go with water issues out here, And as cited by former Chairman Anton Minthorn, that what we do is good for everybody else, good for America, as he said. We've had a number of other legislative acts since 1981 involving our Board of Trustees, a tribal governing body, that enacted those tribal water quality standards back in September 1999, and we enforced Section 401 of the Clean Water Act. Back in 2001, the Environmental Protection Agency formally determined that the tribes qualified for what is called treatment as a state status. And in 2001, the EPA approved our tribal water quality standards. And that's a big step for the tribes, in that the commission is tasked with making sure that we protect, if not introduce features that enhance water quality. The quality standards are not integrated in the revised code, but the code treats them as regulations under the authority of the Water Commission. And the Board of Trustees did enact a new water code, a more comprehensive water code, back in 2003. And then here just recently, this year, we had to make some amendments involving some emergency stream zone alterations in light of all the flooding that we've experienced here, as Kate and Scott alluded to. This past spring, we saw a short window of snowpack in our mountains, and we're seeing considerable melting and runoff up to over, I believe at one stage at the Mission Bridge this past year, we had about 11,000 CFS of water almost hitting the underneath of the bridge structure itself, to the point that ODOT was there, Oregon Department of Transportation, ready to shut down that bridge. But what we're seeing and experiencing is definitely less snowpack, less window up there, earlier runoff, and especially when it comes down in that quantities. How does that impact water supply when our salmon are running, for example? Those are very serious considerations, and because we're going to have to adapt and adjust to these changes, and certainly incorporate and reflect those changes in our water code. Our commission consists of 5 members: the chair, vice chair, secretary, and 2 members. They're appointed by the Board of Trustees to 2-year terms. At least 1 board member sits on the commission, and as I mentioned, we do address a considerable amount of issues on and off the reservation. One example is Walla Walla River Basin. Our commission is very engaged with what's called the Walla Walla Watershed Management Partnership Board, the Walla Walla Watershed Council, and Milton Free Water. And of course, we've been involved in a number of other governmental stakeholder interests in making sure we respectively address water issues and make sure that, well, the water is going to be there, and that we don't do anything to diminish that quality or supply. I mentioned the tribal water rights settlement earlier. As far as I'm concerned, this is probably the second most important historical event in the history of the tribes, only following the Treaty of 1855. But this has been an effort ongoing. I can recall back as early as 2000, 2001, where we've looked at water supply issues, and what came about in the late 1988 and in the mid 1990s, we were able to get the Umatilla Basin project in the lower Umatilla River Basin, in which irrigators were able to forego live in-stream flows or stored flows, and in return get that balance from the Columbia River. And what that does is enable us to free up water for fisheries, and we were able to introduce salmon back into this basin in the 1990s, and been an incredible success story since then. And so it's important as we see that our water code will of course require amendments that reflect and incorporate some of the provisions of that settlement. And it's going to be very important for our tribes because that water is used for our domestic, commercial, municipal, and industrial needs. As we develop, groundwater is really our only source, and so we're very sensitive to make sure that we maintain that equilibrium in our water tables and preserve and protect it for future generations. If anything, part of our values here is that we not only want this water that we've enjoyed for the past 7 generations, its quality and the quantity there, but also for 7 generations ahead. And if anything, you know, the elders that I've enjoyed in the past on these issues, one thing that they emphasize is that we need cold, clean, pure water. And when you have that, it certainly makes it very broad in the sense of how I can use that water, its availability. And so, you know, it's important. We don't do a lot of agriculture or farming or irrigating with water resources out here on the reservation. Nonetheless, though, we are growing and have other economic development plans in place. And anything that we do in the picture is always going to require water. And so the regulation, management, and administration of that is very important because, as I mentioned, or as I started, that it reflects those values and traditions and the culture of the tribes. And again, back to Tamunwit, that this is about water for everybody. So I'm going to, I got one more here. I want to again touch on groundwater that Kate did in her presentation. You know, this is one area that is very important because, as I mentioned, if we rely 100% on groundwater, we don't divert Umatilla water or any other in-stream flows, treat it, put it in the aquifer, for example, like the city of Pendleton does. So we got to be very mindful about how we manage groundwater out here and protect the aquifers. And we saw that critical groundwater depletion that occurred in the lower basin because of what we think is poor management. And it only created a pressure and dependency on ion flows from the Columbia River. And that, again, comes with its own set of problems surrounding the Columbia River because there are many interests involved in that river. We are very engaged with other departments here with the tribes, for example, like our public works. They are researching a new wastewater system and recycling water, something that we think is essential because conservation and using wastewater is being done out there, and how we can replicate that for the benefit and reduce that need on groundwater is something that we need to look at. And we currently have 5 wells that serve the community, and number 6 is coming online soon. That will service water for our resort properties and the South Coyote Business Park, where we're building a building right now, and that well will come online and provide service to those properties down there that is essential for the tribes. So overall, regulating water is a very important part of the tribes' governance here. It goes right along with everything else that we oversee and manage and regulate. Again, it all starts with water, and I certainly want to commend those leaders and elders of the past who've been involved with this, and I certainly appreciate the staff that we have and the members that serve on this. And I just want to go back to Anton's words of, boy, I'm going to go back 25, 30 years on this, but You know, it all starts with our comprehensive plan too. The tribes did that back in the late 70s, and it identifies what are those values, what's important to the tribes. And of course, water comes out much on top, and you know, Antone and a number of other people have been at the forefront of these issues when they were tenuous at the time. Especially when it led to the advent of the Umatilla Basin project. And again, goes to show that we're just not engaged here on the reservation controlling what we have, but we're out there engaged with a number of stakeholders, interest groups, governmental agencies, to make sure that we are all on the same page about how we manage, how we regulate water. And that's going to be even more important as we are dealing this climate change issues. And again, I really thank everybody for participating in this, and thank Colleen for helping putting this on, because this is a very important topic that our future generations are going to have to deal with. And how we set the table and prepare for that, of course, is very important. That we got to be sensitive and cognizant of all the needs out there, but again, still following those caveats that are laid out in our treaty, in our water code, in our 1949 Constitution and bylaws of the tribes. So we have our marching orders, and that's what we do. And so I think the biggest challenge that we're going to see, especially after seeing Scott's presentation, is how are we going to adjust and adapt to climate change when we see a smaller window of snowpack and these floods coming down. You know, how do we capture that, and how do we retain that water so that we can use it, you know, throughout the season for other needs, the fisheries and other needs that are out there. So with that, again, one thing I'm reminded of again is from the elders is that the water needs to be cold, clean, and pure. Thank you. That's what I got for now. And thank you, Colleen.
Thank you, John. That was awesome. I want to take, I know we're running a little bit long, but I'm happy to stay over time for this excellent discussion. And so I wanted to just, if John could stop sharing his screen, I wanted to briefly introduce you to, thank you, the concept board that we will be using for this meeting. So in the chat, I've dropped the link. If you registered for this webinar, it was sent out to you. Oh, it's not working. Give me just a second to copy it. And so this is we're using this for the first time, so please be patient with some of the troubleshooting here. But so this is the board. I'm hoping you can see it. It's got a lot of the impacts of the adaptation plan in it. And so if you want to engage with this, this hand moves the board around. Sorry for the sharp movement. This arrow tool makes it so that you can move things around, and I have a number of preset pictures, but you can also load up some of your own pictures if you want. And so the idea is this is a really visual way of communicating with one another and engaging with this plan. You can also draw little shapes that change color. And so it's it appeals to the magpie person in me, and there's also this text writing here. Control Z undoes everything. And so kind of the purpose of this board is to allow us to continue to engage with one another. And so this is, if you wanted to just kind of leave a very quick comment, you could say, oh, for instance, copy and paste this dams over here and say, like, no more dams, please let's remove the dams, if that is a thing that you want to say. And so you just click the text here, remove dams. And so this is a way that we can all continue to engage with this. And so I wanted to just present that, but then also we have just the traditional way of talking with one another. And so if you want to chat, can you use the raise hand function if possible, or we can just share. But I wanted to make sure that I gave the very first word to a person who has been mentioned many times in these presentations. And so Anton Minthorn, if you are available, it doesn't look like I can unmute you, but if you are able to, we would love to have you unmute your speaker and share whatever you would like to share, because you've been such a huge guiding force in all of this work. So I know technology is not necessarily my forte, and I wish that I could.
Am I here?
Yes,
Am I on?
you are.
Okay. I think it's a really, what would you say, interesting, necessary thing to be able to know what's going on with water, how it's being managed. Because like when John gave his presentation and noted that CTUIR is the homeland of the three tribes, and that the homeland was established by the treaty with the United States government, and it's a tiny reservation when you think about it, but it's just a home for the people, and water is essential to all of that. But there has been tremendous violation of those treaty rights, the policies, and the tribes have lost a tremendous amount of land that was originally reserved by treaty, which includes ceded areas. And we continue to need to do what we're doing right now. We need to have a strong water department or a strong water policy. And there's also a lot of work to be done to restore the treaty rights that were agreed to with the United States government, which they did not honor, and they're going to honor it, but we've got to make them do it because they won't do it themselves. We have to be able to have staff that can get that done. And I think that those of us that have been with water for a long time, working with water, and particularly staff that have that expertise, need to step forward, and they need to work with the other departments regarding water, and they have to work particularly with the tribe of the General Council to know what is going on, and the schools and the children, because ultimately it's the children who's going to end up where we're at right now to manage what we've got. And I think a huge part of that responsibility is being able to work with like federal government irrigation to work with them and to manage them. It's a huge responsibility, but we've got to continue to do what we're doing right now. And right now, it was in the 21st century, as we have restored sovereignty and self-governance and hired our own staff, we'll begin to repair the damage done to treaty rights by not honoring them. So we've got to be able to get them back on track and restore our reservation to its original boundaries. And that's staff that's gotta be doing that, which includes legal staff considerations. But I think there's a right now, after this last flood that occurred, there was a tremendous amount of damage that was done. But that damage, the erosion, has been consistent since the day that settlement took place and transportation has been developed or established in the floodplains. So there's going to have to be some really creative kinds of solutions, planning that's going to have to come up and make sure that all the floodplain damage can be repaired or can be better managed. Right now, the erosion is tremendous, and there's some homes that are going to go at the next big flood that comes down there, and roads as usual. But yeah, I like the presentation, and hopefully, not hopefully, but eventually we will get better with it, so that general counsel can have access to what's going on with water. That's all. Thank you.
Thank you so much. And thank you so much for your years of experience and knowledge that you bring to this conversation. If anyone else would like to speak, I know it's a little bit awkward to unmute and mute yourself. If you do want to speak, please let me know, or just unmute yourself and start talking, and we'll see what happens. And if you want to turn your video on now at this time, I think that would be appropriate.
Colleen, can I add to that?
Absolutely.
All right. Well, thank you, Senator Tom Woods from the Thorn Hollow District. That's Anton's moniker or surname there, and he's been at the forefront, as you know, for quite a while, working in our planning office back in the late 70s, and serving as Board of Trustees Chairman and General Counsel Chairman for the tribes over that tenure. But you know, he's been at the forefront of these battles, and we've had battles, believe me. And but fortunately, the tribes, you know, we take a very diplomatic approach with other entities, and I think we find out that once we learn what we're respectively attempting to achieve, that we find a middle ground that we can reach. We did this with the Umatilla Basin project. But one thing I want to emphasize that Anton emphasized back in the day was developing the capacity and the sophistication so that we can manage this resource. And I think with the people that are even involved with this today goes to show how the tribes have grown exponentially over the decades. And I think we're at the cusp of really have the credibility, we have the people, we have the passion, of course, and to protect this water for our needs, for aquatic species, for wildlife, for fisheries, and for our roots, our berries, everything. And if we can look at those first foods and we see that they're being impacted, maybe that's a barometer of what's going on out there. And if it's telling us something, then we need to pay attention and apply that science and our policies and be able to address this adequately and find some resolution. And I'll go back and quote Bill Burke, who used to serve on our commission for quite a while, is that I can understand the science behind the decisions that we have to make to protect salmon, to protect water. But the one thing I can't understand is the political science. So I'll leave it at that, let you ponder that. But Anton, thank you very much.
Thank you so much, John. Did anyone else have words that they wanted to say? Speak now or forever hold your peace. No, not forever. We'll do many more of these. There are more opportunities to engage too. So sharing on these webinars is not the only way that you can participate in the climate adaptation plan. For those who registered for this webinar, we have been sending out those draft materials, and I'm happy to announce now that those materials are available on the website. I have been tackling website development for the last couple days, and so when you go to it to download stuff, please be gentle with it. And of course, this is still really a work in progress. I know that I feel like everybody's been trying to talk about this for a long time, and now I'm excited to be able to present a lot of the material that's been developed. And so if you want to just email me or call me, I'm not in my office, but I do get those voicemails on my email. And so if you call and leave a voicemail with your contact information and what you kind of want to talk about, I'm happy to connect with you and have a more one-to-one interaction. That concept board will stay up for quite a while, and I will release a closing date on it. We're going to kind of put those images in the chapter 4 of this plan, the community engagement, just to kind of show how it was we really engaged with everyone in the development of this plan. And so if we do have a raffle prize. So we have CTUIR Visual Pro is an air quality monitor that is a really interactive one. I have been beta testing one that the tribe owns here recently, and it's kind of become like my favorite little technology thing in my house. And so we're raffling that off. And so if you registered for this webinar, your name has automatically been included in that raffle. But if you submit, if you talked here today, if you participate in the concept board, if you send me an email, if you write something in the chat, your name, a second slip of your name will be included into that raffle. And so we'll be pulling the raffle on Monday afternoon, so you have over the weekend to get your commentary into this plan. I want to make it as easily and accessible for everyone as possible. And again, if you want to just have a conversation with me, I'm more than happy to make time for that and to meet you at your level and where you are. I know technology is definitely not something I'm overly comfortable with, and so I try to be really accommodating wherever possible. And so I'm going to leave one last opportunity for people to comment if they want. Otherwise, I will respect the time that we all have. And I just wanted to say thank you again to all of our amazing presenters. Thank you, Kate, for the knowledge that you bring. Thank you, John, to the perspectives and the importance of making sure that this finite resource is treated appropriately. And I want to thank Scott also for presenting that modeling effort, even though he wasn't able to be here. And I would love to announce information about the upcoming webinar, but we haven't planned one yet. And so I'm hoping to release that announcement after the holiday. So stay tuned for that. And if you attended today, I have your email. Or if you really want to make sure that you're being kept up to date with what's happening with the adaptation plan, please send me your email and I will bother you endlessly about it. So be careful what you wish for. But it's all really good material, and I'm really thankful to all of the people here today for being here and for contributing to this conversation. So one last opportunity for someone to share. Be bold if you are on the fence. 3, 2, 1. When next are you wanting to share? Okay, well, and with that, we'll conclude the webinar. So
Hello?
Yes, we can hear you.
Since you're calling on me, I'll share. So I was kind of thinking about everything, and I was kind of debating too, and I'm really excited that we're doing the First Foods excursion and the work we're doing with Cultural Resource Protection Program, and going out and finding our women's foods and the cultural resources that in some of the areas that have been locked as access or have not been able to go out to as tribal membership, and to work with cultural resources to secure those fundamental partnerships with some of these land ownerships to get into these areas to see what food resources are currently there on the ground and what's happening to them. And so by being able to go out on reconnaissance missions and looking for these resources, we're finding that there's a lot larger variety of our cuus, which in different species group and different roots that are growing together. And by being able to identify some of these areas, we're going to areas that we just haven't seen as much and be able to watch the population of that area and to continue to check the health of them and be able to look at what's going on climate-wise every year. Like if one year the Bitterroot's there or the next year it's not there, and what's going on within that year. And so by us starting to really look for those resources, bring people out on excursions, and to be able to see what is going on with that area where we are digging, is it more productive? And so we're able to start capturing that vital information and really take a look at creating survey forms related to what we're doing to have a better look at those resources in compliance with what's going on through the climate. So it's really exciting that the work we're leading into and where we're going, and working with the team for the climate adaptation and seeing the plan and being in that forefront and where we can go with the work that we're currently doing. So I'm really excited to see what's going to go on in the future and to learn more about this and to capture as much as we can moving forward and working together as a whole unit. So it's really exciting work, and I'm really glad that we're at this point.
Thank you so much for sharing. And yeah, I think that this work all really ties in together, and that's really the point of this adaptation plan, is to make sure that we're all working together towards the same goal. So I'm going to close the webinar. Thank you again for coming. And again, there will be many opportunities to participate with this. So please let me know if you want to be kept apprised of them. And I hope you have a wonderful weekend, and I hope that you make some time to go and talk with the river a little bit, listen to the river. It has a lot of things to teach us. So thank you again for being here, and achle mashkinuta. Thank you. Bye-bye.
All right. Thank you. Good morning.